Next, let us speak about derivatives of generalized function. Definition. Let's we have some generalized function. Derivative of this function by multi-index alpha is by definition functional what acts on each test function by this formula. Let's discuss a little bit more in detail. So, of course, minus 1 in some power, it's 1 or minus 1, depending on this value. If phi is finite and infinitely differentiable function, when its derivative also has the same properties. So each derivative of finite and infinitely differentiable function also is finite and infinitely differentiable. So this is defined for all functions from D from omega, and depending on the absolute value of alpha, it's multiplied by minus 1 or not. So this thing is defined for each test function and for each multi-index. Also, it can be easily understood what this is the generalized function. So it's linear and continuous functional on D from omega. Derivative is linear operation, so if we have linear combinations of phi's, the derivative of this linear combination will be a linear combination of derivatives. And T is linear functional, so it will be linear combinations of functions from each component. And if phi converge, D converge phi into D converge to phi, then each derivative of phi n also D converge to corresponding derivative of phi. So just according to definition of this D conversion. And if we have in mind what support of derivative is included into support of function. So each derivative of each generalized function is another generalized function, and now all functions have all derivatives, so there is no non-differentiable function. but price is what instead of functions we now have some very complex objects like functionals on some space. And another question, how this strange definition is related to ordinary derivative. Actually, very simple. So let's f is has all derivatives up to d alpha, and let's belong to space of continuous function. And let us consider derivative of t right by f. It will be, let's just write it in detail. If we recall what is regular distribution, we can write this. And next, we can integrate by part absolute value of alpha times. Each time we will move one derivative from phi to f until all derivatives will come to f, and each time our integral will change sign. So it is equal to integral of d alpha f phi dx. And it is the distribution right by derivative of f by this multi-index. So if we have if our function is differentiable, then we can say what is new concept of derivative of generalized function is equal to distribution right by derivative of f. So in case of regular derivative, regular distribution right by differentiable function, we have this nice formula. So it means what indeed this definition fits with classical definition in this term. But we now can define and calculate derivatives of any functions. For example, let us consider omega equal to one-dimensional space of fresh real numbers, and phi is a so-called Heaviside step function. And let's try to calculate derivative of this function. Of course, we cannot speak about classical derivative, but this function is locally summable, and we can build a distribution on the basis of this function. And taking into account the shape of this function, we have integral from 0 to infinity computed for all test functions. By definition, derivative of this distribution is minus distribution of derivative of phi. So it is minus integral from phi dash on dx. We have in mind what phi is finite, so it obtains 0 somewhere below infinity. So we have we can compute this integral. It will have it will be phi infinity, let's say infinity not real infinity, but in some big number goes to infinity, and it's will be equal to minus phi m minus phi of 0, and if m is big, this is 0, and we obtain phi from 0. So the derivative of this distribution give us the delta function of 0. So we can say what derivative of Heaviside step is delta function. if this derivative of distribution is another regular distribution. So let's u is locally summable function in omega, and let's exist some locally summable function in omega such what derivative of distribution right by u is is a regular distribution derived from v. Then v is called Sobolev distribution for Sobolev derivative, sorry, of u. V is Sobolev derivative of u. It means what minus 1 power alpha if we recall what is regular distribution right by f, b, what is the derivative of distribution corresponding to u, we obtain this formula. So it's the equivalent definition of Sobolev derivative. We will consider several examples of Sobolev derivatives on the exercises, and that's all what I wanted to say about generalized functions or distributions.